Hello to everybody. Today we will learn application of the perceptron. But before starting to learning this new topic, let's revise what was the perceptron architecture. As you know, perceptron is one of the earliest and easiest artificial neural model. Actually, there are three distinct features of the perceptron. First one of perceptron using perceptron learning algorithm to find the desired weights and then b values. Second one is it is using hard limit transfer function. Thirdly, net input value for the which we will apply to net transfer function will be calculated by the dot product. That means first, for example, for this perceptron model, first input times first weight plus second input times second weight plus b will be applied to the transfer function. This means we are going to use dot product in this section to calculate net input, and then here we are going to use hard limit transfer function, and then to find the desired weight and biases, we are going to use perceptron learning algorithm, which we have learned in the previous lesson. Let's start some application of the. Let's start to learn some application of the perceptron. For example, to solve three input to class problem, as you see in this data set. Let's illustrate that one. For example, in this example, we have three input. That we have three input and one output. This means we have three input one, or we can tell P1, P2, P3. Let's use P notation because we used to use usually P. Doesn't matter, but there is no difference between P1, X1, P2, X2, P2, P2, and P3. And then desired output, T. For example, in the first case, in our data set, it will be if first input 2, this you can tell X1, also X2, second input, and third input. We can use any notation. First input is a 2, second input if 2, third input is 1. We want output class of the 0. We can tell for 0, A. We can tell, for example, A class will be represented with 0, B class will be represented with 1. We can tell like that. Second one, 1 minus 2, 2. 1 minus 2, 2, and class will be 1. This means class B. And continue, you can continue entering data set or illustration of data set like that. So to solve this problem, we can use one perceptron. Yes, we can illustrate the perceptron like that. We don't need to separate it. We can use summation. In the perceptron, there is a summation and then activation function, and it has output. As you know, output can be 0 or 1. It can be 0 or 1 output. And we have two input now. Input 1 and input 2. So let's do this one in the MATLAB. So to train this network, perceptron network, we will use adapt training function. We have explained how to implement perceptron network and how to train it with adapt in our previous lesson. In this lesson, we will just execute it. Okay, it is successfully trained and finished the result. And you can see the result. Now, if you look at here, look at plus dots, plus classes separated from the circle classes. And then, but since it is a 3-dimension, look at first input, second input, and third input, 3-dimension, we cannot separate these dots in the space, 3-dimensional space, by using a line. We should use like that plain sheet, like sheet. We need to use plane to separate. But this plane successfully discovered by the Perceptron network. So if you want to make it easy, for research purposes, you can use adapt function, and you can see the output. For example, in our output is this one is a output of our neuron. This one is a real output from dataset coming from this dataset, this output, and then this one is a this Y is a output of our neuron, a activated output of our neuron. This one is the error. As you see, after this is the first training result, this is the second training result, this is the third training result. After third training, errors became 0. After first training, we have 2 errors, -1 and -2. This one is the response of the neuron. This one is the real answers. And if, of course, there's a difference between response of the neuron and a real output. That's why -1. After the second training, these are the error. We have only one mistake or error here. This is in the third case, our neuron responding as a 0, but it should respond as a 1. That's why it's an error. But here, there is no any more error. After third iteration, our neuron successfully learned our data set. So if you want to use train function, you can use train function. Let's use train function, because to use the train function, it is easier. And after, we don't need to configure this network, because if you are, if you are using train function or adapt function, first time when you call them, it will automatically configure our network. When you are using train function, instead of adapt, we will use train, and then we don't need to return this one. Only we need to return the trained network object. We don't need this one. To plot the result, we can leave it this one. If you want to see it after training weight and bias values, we can also leave this to 1. All others we don't need actually. So this is our training data inputs. They are the training data output values. After that, we are implementing Perceptron neuron, and we are keeping it inside the net of Perceptron object. And then after that, we are training our Perceptron by using our training input data and training target data. And let's run. That's successfully trained. Okay, you can visually inspect the separation of these 2 classes. Successfully trained our network. Also, they are our trained network result. If our neuron like that, yes, we can combine it after that. Output is a activated output will be for this data set will be 0. For this input case, it will be 1. For example, let's enter this data. For example, if first input 2, second input 2, and there is one more input, you forget it. Third input, because we have 1, 2, 3. Yes, P1, P2, and P3. We have 3 input. Next one is a if. Next one is a 1. If this input 2, second input 2, third input 1, desired output should be 0. And our trained network is telling, first weight, value of the first weight should be -1. -1. Second one should be -3. Second one should be -3. Third one, third weight, value of the third weight should be 3. Equal to 3. And bias term, also bias term should be -1. If you do one neuron like that with 3 input, P1, P2, P3, with 3 weight value and 1 bias value, it will produce 0 in the case of the 2, 2, 1. In the case of the 1, -2, 2, 1, -2, 2, it will produce 1. In the case of the -1, 1, 2, it will produce 1 output. This neuron successfully can learn this data set in this condition. So another question. Solving 3 input 2 class problem. With Perceptron, we have solved it. Solving 4 class problem with 2 Perceptron. 4 class, 2 Perceptron problem with 2 Perceptron. In this case, we have 4 classes. This is important. Let's illustrate this one. Now, how many classes we have? Let's tell A class, B class, and C class, and D class. In the previous question, we have class A and class B. Class A and class B. To code A, we can use 0. To code B, we can use B. This means 1 neuron, it is enough for it. Yes, 1 neuron is enough. Because 1 neuron can produce 0 or 1. But now, if you use 0 for it, we can use 1 for it, but for C, which code we will use? We cannot, there's no more code. That's why we need to change our coding style. For example, for A, let's use the same coding system. For A, 0, 1. 0, 1. For B, 1, 1. For C, 1, 0. 1, 0. For D, 0, 0. 0, 0. We will use this coding system. To produce this coding system, you need to use 2 neurons. 1 neuron is not enough anymore. Yes, you need to use 2 neurons. Neuron 1 and neuron 2. Neuron 1 and neuron 2. It will produce output, activated output 1, activated output 2. How many input we have? We have 2 input, 1, 2, 1, 2. That's why we have P1, P2, P1 and P2. We should connect this input to this neuron and to the second neuron also. We should connect this second input to the first neuron, to the second neuron. This is a first neuron, this is a second neuron. So we can call this naming rule. For example, from first input, weight, from first to first, from first to first, and then weight from second to 1, second input to the first neuron. We can call this, we can use this notation. This one is a weight from first input to the second neuron, first to second input neuron. We can use for this, naming this weight, this notation. from second neuron to the second, from second input to the second neuron. V2, 2. This means we have now 4 weights. We don't have any more 1 weight. Or if, for example, for this neuron, if you have 2 input and 1 neuron, if you have 2 input, 1 neuron, you have 2 weights. Yes, 2 weights. But now we have 4 weights. 2 times 2, 4 weights. Also we have here bias B1. Also for this one, we have B2, second bias. Input of bias always 1, as you know, is 1, 1. Now this neuron can produce these codes. If this neuron activated result of this neuron is a 0, activated result of this neuron is 1. This means it is belong to A class. Example, for example, if let's change color. If first input is a minus 0.5, minus 0.5, minus 0.5. Second input is a 0.5, 0.5. First input minus 0.1, second input is a 0.5. In this case, we want to produce 0 and 1. 0 and 1. Because 0 and 1 code of the A. This network will generate 0, 1 code. This means class of the A. So if you look at this design, now it is not single neuron. We have 2 neurons. Now we can call this one as a network of the perceptron network, artificial neuron network, perceptron in the perceptron type. This is a single neuron. This is here there are 2 perceptron neuron. Yes, we can call it after that artificial neuron network, artificial neural network. We can call it like that. Another case, for example, in this case, for example, for 1 point, look at the big case. Let me go. 1.5 first input, second input is a 1, output will be 1, 1. If 1, let's use another color. If first input is a 1.5, second input is 1, output should be 1, 1. It is a B case. Yes. So I think you understand. If you want to solve the 4 class problem, you need to use 2 neuron, because in that case you can produce these codes. Now let's apply this one to do. Let's solve this problem in the MATLAB. Copy. Let's run till this place. If you run till this place, we have 4 class of data. 4 class of data. Some data coming from the class A, some data coming from the class B, some data coming from the class C, some data coming from the class D. You can see this one, blue ones, green one, red one, and black one. If you want to separate them, you cannot draw 1 line. You need to draw 2 lines. For example, if you draw 1 line like that, and then 1 line like that, and then 1 line like that, we can separate this area into the 4 regions. To understand the codes in this section, you should look at the MATLAB videos. If you look at the MATLAB videos, you will understand what is happening. Here, only we are preparing our input data set. So our input of our training data set staying inside the P, output inside the target. And if you want to see them, we can see them, P and T. view, custom view. Let's see this. This means first input this one, second input this one, output should be 0, 1. If first input this one, P1, second input P2, this one, output should be this class. Or if first input 1, second input 0, output will be 1, 0. And then what is the code of the 1, 0? 1, 0 is belonging to the C class. And let's copy paste the second training section of this code. So we will again train this network, Perceptron network by using adapt function. Again, look at after some training, it finds correctly 2 lines. Yes, 2 lines. Also, you can see the virtually our network. It has 2 input, 2 output. Yes, 2 input, 2 output. If it yes, it is our design also like that. 2 input, P1, P2, and then 2 output, A1, A2, 2 output. Also, we don't have here 1 neuron, we have 2 neuron, neuron 1 and neuron 2, 2 perceptron. Yes. These 2 perceptrons successfully separated our class A, class B, class C, and class D. So you can guess, for example, this neuron can generate 1 line, this another line, 1 line, this decision boundary of the line generated one of this neuron, other decision line of the boundary generated from the other neuron, and then if you make them cross like that, you can divide our data set into the 4 regions. And this neuron network of this neuron successfully can solve these types of the problem. Again, if using adapt function is for research purposes or another purposes, if you want to train it easily, you can use train function easily. Yes. If you are using train function, till this place we are preparing our data set, and then here our network. After that, we can directly train our network. Train. We don't need this output only, we need train network. So if you want to see the trained after training weight and bias values, also you can display them. Weight is here. Weight here. Bias will be set inside this place. Yes. Inside the P, we have input of our training data. Inside the T, we have output of our training data. After that, we are plotting them to this visually to display them. After that, we are defining our perceptron network. After that, we are training, and when training finish, we can print the results. Weight trained, desired weight, and bias values it will show. Also, you can plot the decision boundaries here like that. So successful training. Look at this 4 class separated into 4 regions. So solving 3 class problem with 2 perceptrons. Now in this problem we have this data set. They are the input of our data set. They are the output of our data set. If you look at, we have how many input? 1 and 2 in every input. For A class, we have 2 input. For B also, for C also 2 input. Output, how many output we need? For how many class we have? A, B, C class. So A, B, C class cannot be classified by single neuron, because one single neuron can classify only 2 class. Yes, you need to use 3 class, and you need to use 2 neuron again. Again, you need to use A, E, see. One neuron can classify either 0 or 1. Two neuron can classify either 0, 1 or 1, 0, 0, 0 or 1, 1. This means 4 class. Yes, A, B, C, D. But here we have not 4 class A, B, C, D. We have only 3 class. But doesn't matter. You can use 3 of them. For example, for A, in this example, we have used 0, 0. If output will be 0, 0, we will tell this belongs to A class. If output is a 1, 0, 1, 0, if first output is 1, 0, second output is a 1, we will tell this data belong to B class. If 1, 1, if first output of our network is 1, second output of the network if 1, we will tell is a C class. You don't need to use other option, other code. Other code, what is other code? 0, 0, 0, 1, 1, 1. Other one is a 1, 0. You don't need to use it always. If you need, you can use. If you don't need, you will not use. Here, we need only 3 class. That's why 3 codes is enough for us. So when you run this program, you will see our class A, class B, and class C data will be separated into the 3 regions by using again 2 line, because we have used 2 neurons. One of the neuron will produce 1 decision boundary. Other neuron will produce the second decision boundary. We have 2 input, as you see, P1 and P2, and also we have 2 output. Yes. In that case, we can produce this 0, 0 to output, 0, 1 to output again, 1, 1 again to output. Yes. So solving 3 class problem with 3 perceptron. Pay attention to this point. It is telling us use 3 perceptron. Let's draw it into another place. 3 perceptron. 3 class, 3 perceptron. We have class A, class B, and class C. To code this one, you can use this code. Yes, for example, in our previous slide, we have used this code 0, 0. We have used this code 0, 0, 0, 1, and 1, 1. Yes, and if you want to produce these 2 output, you need to use 2 perceptron. Yes, activated output of 2, activated output 1, activated output 2. Yes, 3 perceptron. Two perceptron you need to use. But in this question is telling, in the next question is telling us, don't use 2 neuron, use 3 neuron, 3 perceptron. It is asking us to use 3 perceptron. 2 and 3. How many input we have? Again, we have 2 input. Input 1 and input 2. Yes, if you look at here, also we have first input and second input, 2 dimension. Let's draw our input also. This one is P1, P1, P2. Example, minus 0.5, minus 0.5, and then 0.5, 0.5. So if there is a 2 input, you need to connect all these input to all these neuron, 3 of them. How many weights we have now? 1, 2, 3, 4, 5, and 6. 2 times 3. Yes, 6 weights. And then we have 1, 2, 3 bias. And how many output we have? Because we have 3 neurons, we have output 1, output 2, and output 3. Now we have 3 output. If we have 3 output, we should change our coding system to the 3 by using 3 binary digit. Yes, A, B, and C. If you are using 2 neurons like that, this coding system is okay. But if you want to use 3 neurons, you can use, but you need to change output coding system. For example, here example, for A, in the example, we have used 1, 1, 1. For B, 0, 1, 1, 0, 1, and 1. For C, 0, 0, 0. This means all three perceptron neuron produce 0, 0, 0. This means this data belongs to the C class. For example, for this data, it should produce 0, 0.5 minus 0.5 and 0.5. It is belong to A class. That's why it should produce 1, 1, and 1 output. Yes, everything is just coding to output. So if you want to solve 3-class problem, you can use 2 neurons. 1 neuron is not enough because 1 neuron can separate 2 class. 2 neurons can separate 4 class. Yes, that's why 2 neurons is enough. But if you want to use 3 neurons, you can use. In that case, you will use the different coding system. For example, 1, 1, 1 for A. Of course, there is other codes, but we haven't used them because no need, because we have only A, B, C class. We can use also 3 perceptron. Again, 4-class problem, 3 perceptron. 4-class problem, 3 perceptron. In that case, we have D class also. D class, yes. Which inputs we have used? We have used which codes we have used? This one. We have A, B, C, D class, and how many perceptron we need to use? 3 perceptron we need to use. 1, 2, 3. If there's 3 perceptron, there will be 3 output. That's 3 output. 3 output we will have. And then for A, for example, we can use 0, 0, 1. 0, 0, 1. For B, we can use 0, 1, 0. 0, 1, 0. For C, we can use 1, 0, 0. 1, 0, and 0. For D, we can use 1, 0, 1. 1, 0, and 1. This means, for example, for this case, let's do this example, this case. If input, also we have how many input? We have 3 input, yes? Also we should change this design a little bit. Yes, and we should add also P third input. Again, we need to connect this input to the every neuron. We have 3 neuron and 3 input and 3 output, and then 3 biases and 3 times 3, 9 weight here. Here we have 9 weights. Yes, we need to learn 9 weights here and then 3 biases from here. For example, we told for this case, in this case, first value is a 0.5 minus 0.5. Second case is again minus 0.5. Third case is a minus 2. Minus 2. If it is like that, we expect it to D class. Yes, D is this one. We need to get we need to find this output. If our network responding to this output, this means our neuron can correctly classify this case or this sample to the D class successfully. Again, when you run this code, it will successfully separated 3D. Look at this is 3D. 3D. That's why we have 3 class. For example, this is class A. For example, this is class B. This is class C, class D. They will separate, and then if you want to separate, Perceptron will separate it by using two plane like that. Yes, but we cannot visualize it in this example, but it will successfully separate. When you look at the mean square error, it is 0. Okay, this means it is successfully separating to the classes. Let's run this code. So when we look at when you look at the result, we can see 100% successfully separated. 100% successfully separated. So in this example, what are there in this example? 4 class, 4 perceptron. 4 class, 4 perceptron. Can you use? Yes, you can use. Actually, to separate 4 classes, 2 neuron is enough. But if you want, you can use 4 neuron, doesn't matter. Only you need to change coding system. For example, for first class, we will tell this code 0001. If output this one, it will be acceptable. Let's draw it. How many input we have? 3 input. Yes, look at, we have 3 input. As you can see, as a X, Y, Z 3 input. Let's draw 3 input. P1, P2, and P3. 3 input. And how many perceptron it is asking us? 4 perceptron. It is telling us use 4 perceptron. 1, 2, 3, and 4. Yeah, 4 perceptron. Also, you need to connect all this one to all these perceptron. Actually, it is a network of the perceptron. Yes. Perceptron. Here we have 3 times 4, 12 weights. Yes, 12 weights. And then we have also 1, 2, 3, 4 biases. We should find this value of the 4 biases and 12 weights here. Also, it has 4 output. Output 1, output 2, output 3, output 4. And then we have how many class? 4 class. A, B, C. It is in the question. It is telling us used 4 perceptron. If question will not tell us use 4 perceptron, we can solve this problem by using only 2 neuron. Yes, because 2 neuron can separate 4 classes. But it is telling us used 4 perceptron. In that case, we need to format the output. First one is formatted like that in this question: 0, 0, 0, 1. If first input output 0, second output 0, third output 0, fourth output is 1, in that case, we will understand that this input data set coming from the class A. C, coding of C, this one, coding of the B, this one, coding of the D, this one. You can write it here. So here there's a one real life example, simple pattern recognition. In this question, we want to try to understand if this pattern belongs to the C or belongs to the T. If you look at here, C, it looks C, this one looks T. And it is a 3 times 3 matrix. Yes, 3 times 3. If you divided image into the 3 times 3 matrix, if you see something like that inside it, it will be letter C. This one letter C. Now we will train our network to classify either it is a pattern C or pattern T. If it is pattern C, our network will produce 0 output. If this pattern belongs to the similar to the pattern T, pattern of the T, our network will produce 1. Also, we have two test cases. We will train our network by using this data set, this data, but also we will check with this test data. Look at this. It actually is not the same. Okay, not same, but our network also should output 0 here. Our network should output 1 because this one looks like this pattern more. So how can you represent these letters in the computer? By using 1 and zeros. Yes. Let's run this code in our computer. Let's first don't confuse this. Actually, this 100 continuation of this part. We have used 3 dot. 3 dot means in the MATLAB, I want to go to next line. Yes. If you want to go to next line, you can use 3 dot. Actually, this line is continuation of this line. There is no differences between this one and this one. Copy. Let's right here. Okay, if you can write like that. They are exactly same. This one and then this one exactly same. Yes, let's tell it C2. This one and this one exactly same. We prefer to this notation. Why? Because when you write this like that, you can see this C pattern here. Look at 1, 1, 1. It is C pattern. But in the network, if you want to apply one input to the network, you need to give it as in the MATLAB as a column vector. We cannot give it as a matrix. Yes, we don't have like that option to enter data as a matrix to the network. If you want to enter a data to network, you should give it as a column. Yes, that's why our data can be like that: 1, 1, 1, 1, 0, 0, 1, 1, 1. But we cannot give data like that. You should give data like that: 1, 1. You should stratify it: 1, 0, 0, 1, 1, 1. You should give to that data like a column vector. And in that case, how many input you need? 3 input is not enough. You need 3 times 3, 9 input. You have 9 input. Yes, 9 input. If you have 9 input, how many outputs? Let's do it here. We thought you need to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. P9, P9, and P1. 9 you need 9 input: 1, 1, 1, 1, 0, 0, 0, 1, 1, and 1. 9 input. You should give data like that. Yes, you cannot give your data like that, we told. Because in network we don't have like that option. 1, 0, 0, 1, 1. You cannot give data like that, but we can give data like that. We need 9 input, and then we have how many letters? We have letter C and letter T. That's why we can use single neuron. Yes, single neuron. Single neuron, because this neuron can produce 0 or 1. If it is 0, we will understand this belongs to C class. If our neuron produce 1, we will understand it belongs to the T class. And then you need to connect all this input to the single neuron. Dot. And this one. We have also one BIOS. Yes. We have how many weights? 1, 2, 3, 4, 9 weights. We need to learn why 9 weights and 1 bias values. Our neuron, artificial neuron, will be in this structure. So let's run this one. So successfully learned. Look at it is 0 error. It is learned. Our model. So let's check now if it is learned or not. For example, this is one C test. Yes, C test value. If you look at it, it is not complete C. Somehow it looks like C. Yes. When we give this test data to the trained network, I should get the result of the C. C is belong to the 0 class. Yes. This should, when I give this C test data set to my trained network as an input, activated value should be 0. Yes. T test data here. Look at it is not exact. If there's one here, it will be exactly T, but it looks like T. Somehow T. Yes, somehow T. When I give this data, test data to my trained network, when I simulated my test data with when I simulated my trained network with test data, I will get the result of the 1. Because T, it should give to class of the T. Class of the T in my coding, it is 1. Yes. This means my network is not know exactly C patterns and T patterns. Also, it knows similar to C and similar to P pattern. Let's change this one. For example, make this one 1. This one is a 0. This one also similar to C. Yes. Evaluate. Now inside the C, there is this one. When you look at here, you can see inside the C these values stratified. And when you execute it, I should get the result of the 0. Again 0. Yes. So this network not only knows C and T letters, also he can classify the similar patterns to the C and similar pattern to the T. So you can do same things in the Python. How can you do? In the Python, we have scikit-learn machine learning library. Scikit-learn machine learning library. Inside that library, we have Perceptron class. You can import Perceptron class and you can use it. But only one difference is between Python and then Python and MATLAB. In the MATLAB, we are going to give data as a column vector. Yes, column vector. If our real data pattern in this structure. Yes, for example, for C, 1, 1, 1, 1, 0, 0, 1, 1, and 1. It is saying inside the matrix 3 by 3. But when we are going to give this one to MATLAB, how we are going to give? Stratified it. After that, we are going to give 1, 0, 0, 1, 1, 1. Yes, we are going to give like that as a column. In the Python, we are not going to give it like a column. We are going to give it as a row. We are going to keep located this number into the row 1, 1, 1, 1, 0, 0, 1, 1, 1. After that, we are going to give our network. We are going to give network. Actually, notation of the MATLAB is a more looks like real life because our neuron, how it is structured, input like that, yes? If there's one neuron, we are going to give this one. Input, for example, first input, 1, second input, 5, third input is 3, yes? In the MATLAB, we are going to give this input to the network as a column vector. It looks like it is matching the entry of the network in real life. Yes, that's why the MATLAB notation is better. But if you want to give this input in the Python, you should put it into the like that row arrow 1, 5, and 3. After that, you can give it to the network. So in the dimension shape of the array is important. Again, this one is a pattern of the C, this one pattern of the T. Yes, pattern of the T, if you remember this one. Yes, 1, 1, 1, 0, 1, 1, 0, and 0. It looks like the T shape, yes. 1, 1, 1, 1, 10, 1, 1, 1, 1, 10, 1, 10, again, 1, 10, 1, 10. It is a pattern, this one is a T, this one is a C. This is a class. Yes, if our network will produce the 0, it will be C. If produce the 1, it will be T. Again, if you want to design a perceptron network or perceptron neuron, we are going to use perceptron method to implement. In the MATLAB, we have used train function. Here, we are going to use fit function. After this one, our network is trained. Our network is trained. After that, you can give the new data. For example, new data, this one. Yes, it was 1, 1, 0. Yes, 1, 1, 1, 1, 0, and 0. If you look at it, it looks not exactly C, but it's somehow C. Yes, 110, 100, 111, 110, 100, 111. This data. But again, you should give in the Python as a row format. In the MATLAB, we are going to give data as a column vector format. So output of this data, output of this one is a y hat. Y hat is a predicted output. And when you print it, it should be 0. Yes. When we give the similar to the T pattern, this one, similar to T pattern, this one, 1, 1, 1, 1, 0, 0, and 0. This pattern. If you put here 1, it will exactly T, but it looks like T now. When you give this one as a row to the network, it should produce 1. Here it should produce 0. Let's do this one in the here in the Visual Studio. And when you execute this code, you can execute it line by line because it is interpreter. Control Enter, Control Enter, Control Enter, Control Enter. We continue like that. Here our network is ready. Here in this network ready. Now let's train here. Now network is trained, and I want to ask now this test case. If this, what is the answer of this case? It should be 0. Yes, answer of this test case is 0. Answer of this test case should be 1 because it belongs to the T case, T class. Answer correct. So if you want, you can implement your Perceptron by yourself from the beginning. Yes, by using pure Python programming language, you can implement it by yourself. But nobody doing this method because already Python, already Perceptron neuron implemented in the Python in the scikit machine learning library, and then in the MATLAB deep learning toolbox, it is already implemented. You can use this implementation. But if you want to implement by yourself, you can implement your code by yourself here, as you see. You can tell class Perceptron. Inside it, we have constructor, and then we have activation function, forward function, and training function, fit function. How it is working? It is simply working like that. Normally, we have like that. For example, if you have two input, yes, input 1, input 2, and bias. You can have input, bias always value of the 1. Yes, we have one bias term here, and then weight 1 and weight 2. Yes, this one is the input 1, this one input 2. But you can change this design like that. It is this implementation using this design. You can give it a bias from here 1, because always is 1, and instead of telling the bias term, we can tell V0, V0. And this one is a X1, first input. Weight is a V1. Yes. Third one is a X3, second input. Weight is a second weight. Yes. This one and this one same. Here you are counting bias as a one input. We know that bias always input of 1. Yes. And instead of using it B name, we can use V0, B sub 0. Yes. Exactly same. This neuron. Summation same. 1 times V0 plus X1 times V1 plus X2 times V2, and with output will be activated output after activation function. So it is using V times multiplication of the V times X. Yes, V times X. Also, when you are initializing, okay, input size, if input 2 plus 1, then I am telling, okay, in my network there is a 2 input, but I will plus 1 because I will use this one as a bias. I am initializing it, and then when you call this Perceptron, when I implement the Perceptron object, this constructor initializing my weight to the 0 at the beginning, 0, 0, 0. All of them will be implementing 0. And epoch training 100 times. If I will not tell anything here, for example, I didn't tell here anything, this means train my network 100 times by default. Activation function is all we told in the Perceptron hard limit. How is hard limit working? We know how if it is less than 0, it will produce 0. If equal to 0 and higher value, it will produce 1. Yes. If X input equal to 0 or bigger than 0, produce 1. Yes, exactly. In other case, 0. Yes, this is the activation function. Forward, we know forward also how to calculate forward. First input times first weight, second input times second weight. How we can do dot product by using dot product. After when you find the multiplication of them, we will give it the activation function. Yes, here we are calling it Z. Yes, if you separate here, let's separate here. Is a net input. After that, let's separate activation function output. Is the activated output. In our previous slide, we have used here N, but here we have used Z. It doesn't matter that. This means when we calculated Z value, we will give it to the we'll apply to the activation function. Yes, we will Fn, Fz. In our previous slide, we have used N notation, Fn. Now we will give as Fz when F that is defined in the equation. It will go to that function and return result, and we can find value of the A. And how we will update these values? Like that. We know also update function. V new is equal to V old plus delta V. Yes. How much we need to change old weight value? How much amount? This amount. What is this one? Error times P. Yes, error times P. If error is a -1, it will be minus time P. P is the input, our input here inside the X. Yes. We'll update, training function will update our weight according to this formula. So let's run this one in our input is a X. There is a here, as you see, there is a C. Yes. Inside this one is a T and target 0 and 1. When you run this, when we run this one, it will give us weight. Yes, we told that we will use first weight as a, in our design we have used our first There's our design. I couldn't see what we can do it again. It was PowerPoint, yes. Sorry. We told we can design like that as a bias, yes. 1, P1, P2, P1, V1, and V2. Or we can design this, also we can do this one. Instead of illustrating bias here, we can represent here as another input. Yes, for example, we can tell this is always 1. We know that always this is a 1. This is a, instead of B, we can use V0. This one is a P1, P2, and V1, V2. But in our character recognition example, we have 9 input, yes? Not 9 input. First one will be used as a bias term. That's why this weight is a value of this one, 0. Second one is a 0. This is 0. Last one is a -1. Last weight, night weight is a -1. Yes, it will give this. If you will set the weight and weight values like that, it will always be able to separate the C from the T. So if you want to be, you are a computer engineer, yes, you should, you can investigate any object in MATLAB and even in the Python by yourself further. For example, we have one network object in the MATLAB. Yes, we can use this command to investigate them. Let's investigate by using this command. What can you investigate about your command? For example, look at here, we have one net object. Let's use one simple network before investigating to make our life easy. Let's use this network. Let's clear the environment. Now our aim is to investigate our objects. We know that when you run this one, it will solve one problem. Yes. It is separating these two classes. Yes. And train network stored inside training algorithm will train our perceptron, and it will store in our train network into the net. Yes, net. So what can we discover about this net object? You can discover this one. When I told this one, okay, list me methods which I can use together with my network object. Is one perceptron network object. I know that, and which method is available. For example, adapt method I know how to use. Yes. Display I don't know, but we can guess it is displaying something. Init initialize, yes, to wait. We know from our previous lesson. Simulation function, we know this one, how to use with view, for example, very common. Let's use the view first. We know that one. ViewNet. Yes, this one. There are many methods which available, and you can use this method together with this network object. Also, there is one disk here. Yes, we can guess there is some. It is showing some information about our network. This information. It is telling, first of all, is that Perceptron neuron network. Yes, there is some information here. Input weight, layer weight. In this network, we don't have layer. We have only input weight, bias values. And then also there is some methods available. Adapt method, configure method. We know all these ones. Yes. For example, we have used adapt function to train our network. We know it. We know it. Also, we have used train method to train our network. We know that one. Also, we know ViewNet. Yes, VNet. We know this one also, VNet. It is displaying, virtually displaying our design of network. Yes, we know that one. Configure, we know it is if it is configuring input and output number, and then it is initialize weight at the beginning. We need to choose weight and bias values. It is initialized then for the perceptron to the 0 value, and then initialize when you anytime if you want, you can again initialize after training, for example, network. If you want to start from beginning, you can initialize to network to do again 0 weights and bias values. Sim is out of our topic, but if you want to see, we have here simuling. This command is you can use this version of your neural networks, but we are not interested with this one simulation. We unconfigure is the reverse of this one. You can configure or unconfigure your things. We don't know about this one, for example. We don't have too much information about this one. We didn't see before it. Let's try to discover what is it. Perform. First of all, we know this function, this method can work with our network. Even it is going to give some things. You need one network object. In my application, I have already network object, and it is target values. Look at target values, and then Y values. Y values are calculated values or response of the network. Target values. That's net. That is my target here. They are my target staying inside the T. I have also T, but I don't have calculated response of my network. Yes, in this code, I don't have response of my network. They are the real output target. Y, also it is expecting from me Y, but Y means calculated or response of my network. How can you find response of network? I know that because we have used this simulation to see the response of the network. I can use again sim function to get the to simulate my model. To simulate my model, I should tell which network I want to simulate. I want to simulate this network, Perceptron network I want to simulate. And then if you want to simulate which input you want to see result. For example, my input is inside the P. So to see my performance of my network, it is expecting from me three things. If you want more information, you can press F1 and you can see more information here. Forget it has minimum 3 requirements. Net, which network object you want to see, which network's performance you want to see. What is the target value? Target value is a real output. And Y is a calculated one. Or calculated output or response of my network. How can you find the response of my network? By using simulation function. I can give them my trained network object with my input. What I can ask, what is, if my input is 1, what is my response? Yes, it will produce. And I see, it will tell my performance of my network is 0. This means there is no error. It is successfully predicting all these inputs, and we can also see this same result from here. If I run this one, forget. Virtually I can see all dots successfully separated from each other. Also, I can see confusion metrics. Confusion metrics is telling me 100% training data, 100% separated to 2 categories, 0 and 1 category, separated. So if you want to investigate which methods available about your network, you can use these things. Method views will display list of the available methods related to this network object, or you can use method net command. You can do the same thing in the also in the Python. How can you do? In the for example, here, if you want to see the available methods related to my network object, you can use dir command and Control Enter. Control Enter. And let's run again. So you are going to see many methods available. Yes, there are many methods available. But some of them we are not interested. For example, if let's filter this underscore methods. If you want to filter it, you can filter by using one functional programming. In the functional programming, without making loop, you can do loop as you see here. For example, go to this one, and then inside it, and if starting with underscore, don't show it. Okay, if make it false and don't list. You can list only. I want to see some methods. Yes, that's why Control Enter and Control Enter. It is only showing to me some relevant methods, available methods. Yes. For example, let's see some of them. Coefficients. It is we can use it. For example, intercept. We can use it. Number of iterations, for example, let's use this one, copy. Net and number of the iteration. It is telling 7. This means my network iterated 7 times. 7 times it is trained. It is after 7th turn, all error became 0 and stopped to training. Yes, and I want to see, for example, in the MATLAB, if you want to see bias and weight, you can see. Also, we can see here bias and weight with coefficient. Inside by using coefficient method, we can see the after training, they are the after training value of the weights. Yes, they are the after training value of the weights. Also, intercept. We can see the intercept is the meaning of intercept here in the Python bias term. So after training, my weight should be these values, should get this value. Bias should get these values. In that case, my network in the scikit-learn Perceptron can separate C letter from the T letter. And you can see more, you can use all these methods and you can discover all these methods, what are they doing by yourself. So what is the limitation of the Perceptron? First of all, Perceptron can produce 2 outputs, 0 or 1. Yes, because it is using hard limit function. That's why it can separate only 2 classes. Or it can solve classification problem. It cannot solve the numerical prediction problem. If your output is a continuous values, for example, how much degree will be output, how much degree will be weather tomorrow. If you want to predict this one, you cannot predict because it is a continuous value. But if you can predict this one, if tomorrow weather will be sunny, rainy, or cloudy, we can, because it is a classification problem. First of all, first limitation of Perceptron, you can solve only classification problem. You cannot solve the numerical prediction problem. Second, if your data set is a separable, linearly separable, if you use adapt function, finally you'll find it is making you guarantee you'll find one result. But if it is not separable, your data set, if you don't have a separable data set, this means Perceptron cannot solve this problem. For example, there are 3 logic problems. Logic gate. AND gate is a linearly separable problem, or linearly separable, but XOR is not separable. What does it mean? For example, to understand this one, let's plot their output. For example, if this one A, this one B, 0, 0, this one, 0, 1, 0, 1, this one, 1, 0, this one, 1, 1, this place. Yes. Let's plot this one, A and B. 0, 0, this place. 0, 1, 0, 1, this place. 1, 0, this place. 1, 1, this place. Yes. I am indicating 1 if output is 1 with cross. Yes, if output 1 with cross. This one A and B. If I will plot this one, 0, 0, this place. 1, 0, 0, 1, 0, 1, this place. 0, 1, 0, 1, 0, output is 1, cross. 1, 1, this place, output 0. Now, let's see if they are separatable or not, linearly separatable or not. For example, to separate a circle from the cross, I can use this linear line. Yes, it is linear line separating this class from this class. And also you can separate. But if I will draw this one, I cannot separate. Yes. If I will draw like that, I cannot separate. Yes. I can separate like that only. Or I can use 2 line. Yes. I need to use two line. One of them like that, one of them this one. Even if I will use two line, I cannot separate because this class and this class, same class. Yes, they have the same class. There is no three class. Class 1, class 2, class 3 here. But here, class 1, here, class 2. Here, there's a class 1, class 2. Yes, but here, there's a class 1, class 2, and class 3. Even with two line, it is not correct classification. Yes. Non-linear. Yes, this means if you have like that problem, you cannot solve this problem with perceptron. But if you have problem like that, linearly separatable AND gate, for example, OR gate, you can solve this problem with perceptron. So what is the difference between adaptation and then training? In our previous lesson, we have tried to briefly explain what is the training and adaptation. First of all, if you want to use train, you can use in the MATLAB, you can use train function, train method or function. And if you want to make adaptation of your network, you can use adapt function. When can you use train? When can you use adaptation? For example, if you have data set like that, x1, x2, and output target value. For example, 0, 0, 0, 0, 1, 1, 1, 0. This is also 0, 0, 1, 1, and 1. If you have like that limited, finite, limited training data, you can use train. Because you can train by using all this data set, and you can get one trained network object. You can get one trained network object. But if your data set is not like that finite, there is many sequence of the input and target vectors, unlimited, like that. If data continues to coming, always data coming. For example, you have one sensor, here sensor, and data continues to coming to you. 0, 1, 0, 1, 0, 1, 1, 0, 1. Always data is coming. Yes, or new cases. Every time new cases came. In that case, to use this technique is better, because if new data come, you can instead of retrain all network, you can give the new instance to the network, and then you can make adaptation of your network to the new coming data. But if your data is limited like that, in that case, it is better to use training method. So what is the difference between incremental learning and batch learning? So again, in the incremental learning, we have neuron. Yes, we have neuron. For example, we have two input neuron, two input of the neuron, P1, P2, and then we have activated output. Yes, in incremental neuron, we are going to give this, we are presenting this case to the network. If, for example, 0 and 0, output should be 0. And then if output is not 0, there is an error, means we are updating weight and bias term. Yes, we are updating weight and bias term. Again, next time we are presenting this case to network. If desired output not getting, this means there is error. Again, we are updating weight and biases. In incremental learning, we are applying data set one by one. In the batch learning, we are, if in our data set, if there is a 4 case like that, we are going to give all this case one by one, and we are measuring error. Again, second case, we are measuring error, and third case, we are measuring error, and then fourth case, we are measuring error. After that, we are summing this error, and we are going to see some error. If there's error, we are updating weight and biases. First of all, we are going to give all cases one by one. At the end, if there's error, if summation of that errors is still error, we are updating bias and weight terms. But in the incremental learning, always when we introduce one input, one case, if there's error, we are updating our weight and biases. But in the batch learning, we are going to give a set of data, set of input from training to network. If there's an error, we are updating. If there's no error, we are not updating. And then we are going to give second set of the data, and we are measuring the errors. If there is some of the error, if there is an error, we are again updating our network. So to make incremental learning, you can use training or adaptation method. Again, for batch learning, you can use training and adaptation method. But if you want to apply incremental training, if you want to use incremental training, it is better to use adapt function. If you want to make batch training, it is better to use train function. We didn't do this one, but if, for example, if you want to do batch training, before calling the train function, you can tell, okay, set my train function to the train batch. For if you want to make incremental training, before calling the train function, you can set the train function to the train sequential. By the same way, you can continue like that. For example, if you want to use another method of the incremental learning, you can use train random function. You can set this one. In that case, in this case, it will make batch training. In this case, it will be incremental training. It will be incremental training here, or here also, it will make incremental training again. So we have finished today's lesson. See you next lesson.